Air blast circuit breakers explained. In the realm of high voltage protection, air blast circuit breakers, ACBs, stand out for their ability to interrupt massive electrical currents. Unlike their low-voltage counterparts that rely on air at atmospheric pressure, air blast ACBs utilize a different approach, a forceful blast of compressed air to extinguish electrical arcs and safeguard the circuit. The power of compressed air. The core principle of an air blast ACB revolves around the rapid cooling and removal of ionized gases during an arc fault. Here is how it works. Fault detection. When a fault occurs, the breaker's trip unit detects the surge in current. Contact separation. The trip unit triggers a mechanism that rapidly separates the fixed and moving contacts within the breaker. Air blast activation. Simultaneously, a high-pressure air valve opens, releasing a powerful jet of compressed air stored in a reservoir. Arc extinction. The compressed air blast is directed towards the arc path. This forceful air stream cools and extinguishes the arc by removing ionized gases. The air blast sweeps away the ionized particles that sustain the arc, effectively interrupting the current flow. Cooling the arc path. The compressed air rapidly reduces the temperature of the arc, making it easier to extinguish. Anatomy of an air blast ACB. An air blast ACB comprises several key components. Contacts. Fixed and moving contacts made from a durable, high-conductivity material like copper or tungsten. Arc chute. An insulated chamber surrounding the contacts that guides the air blast and helps extinguish the arc. High-pressure air system. A compressor, reservoir, and valves that store and release the compressed air used for arc quenching. Tripping mechanism. A system that detects overcurrents or short circuits and triggers the opening of the contacts. Advantages of air blast ACBs. High interrupting capacity. Air blast ACBs excel at handling enormous currents compared to other types of breakers. This makes them ideal for high voltage applications. Fast arc quenching. The forceful air blast extinguishes arcs very quickly, minimizing damage to the breaker and surrounding equipment. Suitable for outdoor use. Unlike oil-based breakers, air blast ACBs are well suited for outdoor substations due to their non-flammable nature. Applications of air blast ACBs. Air blast ACBs are primarily used in high-voltage applications where a high interrupting capacity is crucial. High-voltage transmission lines. They safeguard power grids by interrupting faults and preventing widespread outages. Substations. These breakers protect transformers and other high-voltage equipment within substations. Industrial settings. Air blast ACBs can be found protecting high-power industrial motors and generators. Limitations of air blast ACBs. While powerful, air blast ACBs have some drawbacks. Complexity and maintenance. The compressed air system and high-pressure components require more maintenance compared to simpler breakers. Bulkier design. The need for a compressed air system makes these breakers larger than some other types. Noise generation. The release of compressed air can create significant noise during operation. Conclusion. Air blast circuit breakers have been a workhorse for high-voltage protection for decades. Their ability to handle enormous currents and their suitability for outdoor applications make them a vital component in power transmission and distribution systems. However, their complexity and noise generation necessitate careful consideration when choosing the right breaker for a specific application.